welcome back to my channel. I'm Brian Kafke, and we're continuing the Master Databricks and Apache Spark series with lesson 34, using Apache Arrow with R to get massively faster performance of R code on your Spark cluster. Before I jump in, I want to ask you to join my inner community on Patreon, where you'll get ad-free videos and direct access to me among the benefits. We'll start by talking about the performance bottleneck. Then we'll talk about Apache Arrow to the rescue, and we'll follow it up by walking through in detail code that will enable Apache Arrow on Spark. So let's talk a little bit about Arrow. On the left, you see an example of two nodes. You could have any number of nodes, of course, in a cluster. And we have our code that we want to run distributed over our cluster. So it's going to be running in parallel over our cluster. In order to do work, data is going to have to be extracted from our, in this case, a user-defined function, and serialized, which is sort of like converting it to a JSON text file, right? It's going to serialize it. Then it's going to send it over to the Java virtual machine, the JVM, where it can be deserialized, packed back into a Spark data frame to be worked on. And it's going to be doing this back and forth. And that's because the R runtime stores things in a different format than the Java virtual machine. When the JVM is done with what it's doing, it's going to serialize the data back again, which will be deserialized back into the R environment. So you can see this is a lot of overhead. If we could avoid that by having no conversion, as you can see in the diagram on the right, we'd be in a much better position. The Java virtual machine is storing data in a format called Arrow. And on the right, you can see that the R environment is also using Arrow format. Because they both use the Arrow format, there's no more conversion needed. They talk the same language and everything runs much faster. This is kind of almost magic, right? Because when you install Arrow, it kind of just transparently replaces both the JVM format and the R format. In fact, it can be used with Python and a number of other services as well. And it works the same way. It just magically replaces how the data is being stored behind the scenes in memory so that it's compatible and can be very quick, and you don't have this kind of communication slowdown. So I might say, okay, Brian, what's the benefit? So let's say I use Arrow and it's supposed to be really fast. What do I get out of it? Well, the functions that can directly benefit from using Arrow include these functions: create data frame, collect, deapply, which runs that R code on the cluster that we talked about, deapply collect, gapply connect, and basically any custom R code that you're running on your nodes. So it's pretty big benefits here. So without Arrow, the data is going to be constantly deserialized and serialized back and forth to get the process done, and that's a real big bottleneck, which is going to slow down your processing. As of Apache Spark 3.0, there's a new vectorized implementation which is going to really leverage Apache Arrow to exchange directly between the JVM and the R driver. I do want to emphasize that Apache Arrow is not just for R, and it's not just for R and Python. It actually works with all of these different services as a way to make the communication between them more efficient. So let's get into the code and see how it really works. As I mentioned, these are the functions that can benefit by using Apache Arrow. But before we can get that benefit, we have to enable Apache Arrow and make sure we have the Arrow library installed on our cluster. I'll put a link in the description where you can get this notebook so you can run it and try it out on your own. It has here also some links which are really useful. This one on using Apache Spark 3.0 and this one on using the R Arrow package from CRAN. How do we know if Arrow is already installed on a cluster? Well, we can run the function install.packages as shown here. And in this case, because I've been practicing, I have already installed Arrow, but maybe you don't have it on your machine. Well, there's a couple of things you can do in that case. One way you could do it is to just run install packages and then give it the name Arrow. And I'm commenting this out because I don't want you to accidentally bring this notebook in and run that command, because it can take 20 minutes to a half hour just to run. The disadvantage to this method of just doing this right in your notebook is that, yes, it will install the Arrow package on your cluster nodes as needed, but the next time you start the cluster, it's lost. So anytime the cluster shuts down, it goes away. So a better way to do it is to go to your cluster as shown here, go into your libraries, and then you can say install new, go to CRAN, click on CRAN, and then you just type in Arrow and say install. I'm not going to do that because I have Arrow installed, but if you do, be prepared to wait maybe up to 20 minutes or so, because it took mine a while to install the first time. But that's all you have to do. You can see here it's already running, so we're good on that part. Again, once you've done that and you've installed, you can run on your notebook install.packages, and you can see that, yeah, Arrow is there. The other thing we're going to need to get things set up is the Spark R package. The Spark R package will let us configure the Spark environment. So I'm going to just do library Spark R. To take a look at any given configuration setting, we use Spark R, and this is case sensitive, so Spark lowercase with the R capital, .conf, and then we give it the name of the configuration setting we're interested in. In this case, the Spark SQL execution arrow Spark R enabled. And we can see that it says true in this case. But if it didn't say true, how would we set it to true? We can go here and say Spark R session, and then just set the configuration this way. And this is just a format. I copied this off a blog, so it's nothing rocket science here. If I set that to false, it would turn off the enablement of Spark R Arrow. But this is going to set it to true. And then I can check it again to see that it's enabled. That's good. The reason I didn't have to enable it is actually because Databricks had it enabled by default, which is great. But it does not install the Arrow library by default. You do have to install that. Depending on the version of the Databricks runtime you're using, you may not have this enabled by default, so be sure to check it. A quick way to check your Spark configuration settings is just by doing sparkr.conf with no name of parameter, just open close parentheses, and then you can see all kinds of different settings in here that you can verify. There's another setting you might want to take a look at, which is the Arrow batch size. When you're doing something like running a user-defined function, especially if you're doing a grouping one, then it's going to have to batch the data into some sort of set number of rows for it to process them, right? And that is controlled by a setting called max records per batch. The default setting for this is 10,000, but you can change it to what you want. Be careful though, because if you set it too high and there's not enough memory on the cluster nodes to support it, you could crash your cluster. If you set it too low, you'll get poor performance. So you may have to play around with that a little bit and see how it goes. I would say just leave it at the default and see how that works for you first. But you can see here, if I just display it, it shows me 10,000. I can use lowercase session, uppercase I, NFO, to just get information about my session. And that's kind of useful. It's not really relevant directly to this, but you can see what R version you're running, platform, etc. There's a bunch of interesting information. It shows me also what packages I have attached. And also here I have Arrow attached because I've been running this notebook already. At this point, you should have Arrow installed on your cluster. Whether you went to the cluster itself and did it, or you did it directly in the notebook, you should have it. Now we can use the library Arrow by using the library statement with Arrow, and we can check the version by using the package version function. Great. Arrow has some useful file functions that we may want to take advantage of. The link here will take you to more information about those. But one of them is that in R, I'm able to now write Parquet files out. So I can say write Parquet, and I'm going to use the built-in data frame called mtcars. That's just automatically given to you as part of R, so we can use it in Databricks without any other work. So I'm going to take mtcars and I'm going to write it to dbfs filestar mtcars.parquet. I will warn you, this formatting is very confusing because sometimes when you're using specifiers for paths, it's dbfs colon, and then you treat dbfs as a drive. Other times you completely ignore the dbfs and just say filestar or something like this. But in this format, it treats dbfs as if it's a namespace in your folder structure. So it treats it like the root folder. So I'm going to say write Parquet and then mtcars. I'm going to write it out. Very simple, right? It will overwrite it if you run this multiple times too, so it won't give any errors. Now I'm going to use library Arrow, just make sure we have that again. This time I'm going to use read Parquet, the path to where we just wrote our file. So I'm going to read it in. I'm going to store it in srdf, so Spark R data frame underscore cars, and then I'll just display cars to show that it works. So that's kind of useful. I can store things in Parquet. Parquet is really the format used by Delta Lake, except Delta Lake adds a bunch of logging and things around it, but it's ultimately an efficient way to store data. But if we're using Arrow a lot, we may want to store the data in the same format Arrow stores it in memory. So the closest way to get to that is using the format called feather. So here we're going to call write underscore feather, and we're going to make sure we specify the Arrow package. That's recommended in the documentation. Call it Arrow : that's the package, write feather. we're going to write the empty cars file again. This is the built-in data frame. We're going to write it to empty cars.feather. And again, we're going to now read it back. We're going to read back from this file that we just wrote. We're going to use read feather, again prefixing with arrow : : We're going to make sure it gets the read feather function from the right package. We're going to read it into srdf_cards feather, and then I'll just display it. Now the key thing to remember about feather is that's the format that Arrow is using. So if you're going to be doing a lot of work with Arrow, you may want to take the data and store it in feather format and then just bring it right back in to minimize any kind of conversions. So let's take a look at the performance improvements we can expect when we're using Apache Arrow. First thing I want to say is if you're using open source Apache Spark, you may find that Arrow was not enabled. You can start a session and enable it by doing sparkr.session as shown here, master local asterisk, and then spark config, and then you use the list. And basically you're enabling Arrow execution on the fly as you start this session. I'm not going to actually use this because it's already started and I'm already set up in Databricks. Let's talk about the functions that benefit from using Arrow. Again, we're going to bring in our library again, but we mentioned earlier that create data frame is one of them. So if you remember again, empty cars is just a built-in data frame. It's a local R data frame. I'm going to convert that to a Spark data frame by using create data frame, and that's going to store the result into spark_df. Then I'm going to use collect and collect it so that I can display it back. Both create data frame and the collect function will benefit greatly by using Arrow because it avoids all this conversion back and forth. However, collect will bring back the entire data frame, whatever you're collecting, to the driver node. So if you bring too much back, it can still crash your driver, but it'll crash it faster. Let's just run that. And here I did the collect and you can see it worked. The other thing that we get better performance on, and probably an area that people are going to be particularly interested in, is when you're running your own R custom code on the node. And you want to get the performance benefits of Arrow. So here we're using dapply to call our function. We're going to pass in our data frame. Here's our function being defined, and it's taking RDF as the data frame coming into it. And then we're going to be doing just adding one basically to the gear which is on that data frame. So each gear will get added by one, and we have to tell it what to expect back. It's going to be returning the struct type function, a column called gear, which is a double. Now we can do that without Arrow, but it would take a lot longer, especially on a large data frame. You can see here it worked pretty quick, but so that's the main thing. By doing this, we're going to get massive improvements when we do arbitrary code, as I call it, with our own custom R code running on the nodes in parallel. You can also do group applies, right? So if we use the group apply, then we're passing group apply, Spark data frame again. Our grouping column is gear. Here's our function, which takes in key and group. It's taking this function and creating a column called gear, which is the key column that came in. Then it's taken displacement, and it's taking the mean and then the group of displacement. So it's taking the average here, and it's taking the average displacement for the group and saying, is that greater than the displacement? So it's going to be passing that over each row and returning true or false. As before, we see it needs a struct type back, and it's going to be returning the gear, which is the value of how many gears, right? And then our displacement, but this is going to be now a Boolean. So if we run that, we see we get our results back, which is great. There is another version of gapply, which is gapply collect, which will also benefit from Arrow, and dapply collect, which will also benefit from Arrow because the collect function itself benefits from Arrow. It doesn't require that deserializing conversion to happen. So wrapping up, we talked about the performance bottleneck, and what you learned is that the different parts of Spark don't talk the same language. And we saw that underneath the covers, Spark is all written in Scala, and Scala uses Java. And so it's using the Java virtual machine, the JVM, on all the different cluster nodes to actually do the work. The problem is R don't speak JVM, right? R doesn't speak that language. It doesn't store data in that format. It has its own format. And so in order for your R code that you want to run in parallel on the cluster nodes to work, it's going to have to keep converting the R data stored into the JVM storage format and back and forth throughout the process, which is extremely slow. And it's not just true of R, but it's also true of Python and other services. We learned that Apache Arrow solves this problem by essentially just swapping out the internal storage used by the different services, in this case the JVM and the R runtime, to be in a common, highly efficient, highly compressed column store index called Arrow. And then we walk through in detail how to check and make sure Arrow is enabled on our cluster and that we have the Arrow library installed as well, or the Arrow package. Then once we have all those pieces, we walk through some of the scenarios with code that will benefit massively by using Arrow. That's all for this time. Please leave your comments below. Glad to hear them, answer questions. Please subscribe if you haven't already, and make sure you turn on notifications so you get notified of new videos. And of course, a reminder, please consider supporting me on Patreon. Link in the description. Until next time, I'm pulling for you. We're all in this together. Thank you.